Boom. Hello and welcome back to Differential Equations, section 2.5, part 2, which is variational parameters. So we've talked about non-homogeneous second-order differential equations, where you had equations such as, say, ay double prime plus by prime plus cy equals to f of x. Now, we know that from this part here, we get yh, which is homogeneous part, and then when we use everything, we get yp, and then we combine those where the total y as a, well, I used x, so y of x would be yh plus yp. And we did already method of undetermined coefficients, where we took some derivatives and did whatever we had to do to come up with yp, and then added together superposition of those to get the solution to the entire problem. Now we are going to take a look at variation of parameters. Now, after the long derivation, we get to this formula which we use to get the solution. And remember that your and whatever the formula I put up, that's only for yp. Your y homogeneous is still whatever we learned earlier with constant coefficients and can have any of the flavors that you get over there. So the problem now, which is to be solved by variational parameters, will have y homogeneous, which would be c1 e to the r1 plus c2 e to the r2 x and x. There we go. Or c1 e rx plus c2 x e rx, or e to the ax and then c1 cosine bx plus c2 sine bx. So you will have any of these three as the answer to the homogeneous case. And that's all studied in 2.1, 2.3, whatever, the homogeneous part. Variational parameters is what we do for yp. And the formula for this is negative y1 of x integral y2 of x times f of x divided by Wronskian of x dx plus y2 of x integral y1 of x f of x divided by Wronskian of x dx. Ta-da! There we go. Variational parameters. Ready? Let's take a look at the example. Variational parameters. Aha. Sheesh. All right. So how about 48? Problems 47 through 56 are all variational parameters problem. That's 161. So y double prime minus 2y prime minus 8y is equal to 3e negative 2x. First we solve homogeneous case with the characteristic equation. So r squared minus 2r minus 8 equals to 0. Factor this as r minus 4r plus 2. Get r equals to 4 and r equals to negative 2, which gives us our homogeneous case. YH of x is equal to C1 e to the 4x plus C2 e to the negative 2x. Now what you see here is a typical exam question for Thursday. Just this part, because this is what you studied in 2.3. What follows is variational parameters, which is not on the exam on Thursday, but it will be there if you pick to have more exams. What happened? Good.
So y of h versus the y of p, you said y of h homogeneous, but it's not equal to 0.
No, but you ignore this to solve that part, and then we will use it later for the whole thing.
That's why it's homogeneous up top.
Yep, because you're, that's why I put 0 here. We ignore it. So now, what we found is that the y1 is e to the 4x, and y2 is e to the negative 2x. And what we do from there is we find the Vronsky first. So that's y1 prime is 4e to the 4x, and y2 prime is negative 2e to the negative 2x. And then we stuff that into the matrix. And we run the thing. So negative 2e to the 2x minus 4 e to the 2x, negative 6e to the 2x. What happened?
Oh, never mind. You subtracted the e to the 2x and that's 2 to the 4x.
Good. So now that we have Vronsky, we can do the, we can start building the YP. I will write the formula one more time. It's extremely easy to remember it actually. It's YP is equal to negative y1 integral of y2 f over w dx. Now all of these are of x. Plus y2 integral of y1 f Vronsky dx. See that? So you start with negative y1. y2 goes in the integral, fw, and then y2 is positive, y1 goes in the integral, fw. So let's plug everything in. Negative y1 was e to the 4x, integral of y2 was e to the negative 2x times f, which is e to the 2x, right? No, 3 to the x. Divided by Vronsky negative 6 e 2x dx plus y2 is e to the negative 2x integral e to the 4x, again 3e 2x divided by negative 6e 2x, and then dx. Cancel. This is cancel 3 and negative 6, put negative 2 outside of the integral. So I have now negative 1/2 and negative in front creates positive, so 1/2 e to the 4x integral of e negative 2x dx. And then over here negative half goes outside, e negative 2x integral e 4x dx. Jawohl.
Jawohl. Those moves that you made, muy rápido. Can we go back and see what was that move that you just did right there?
Which move?
He says the whole simplification of all.
You just simplified.
Well, e to the x squared, e to the x squared, they cancel because they're the same. And then number 3 with number negative 6, they cancel, and that's 1 over negative 2.
So you were just copying that bottom line right there?
Yep, just copying with halves outside. That's all I did. Haven't done any calculus yet. What happened?
Where? Going so fast.
It should be 3e to the negative 2x, not 3e to the
Where?
original equation.
Original equation. What
So yeah, the original equation we gave it.
is negative? You know,
I missed
so this is negative, and this is negative. All right. So now they all cancel in the second one. I have nothing in the second one because they all canceled. Because 4 minus 2 is 2, and then minus 2 from the denominator, they all die in the second one. And the first one is e to the negative 6. Right? Minus 2 is minus 4, minus another 2, minus 6.
Oh, minus another 2. Oh, the bottom. Okay.
Yes.
Okay. Alright. Yeah. That makes sense. I didn't see that negative.
Which one? Which negative?
What?
Which negative you didn't see?
Well,
I'll zoom in.
or negative 6 e to the 2x. Or no, because it's on the denominator, that's what it's.
Yeah.
6x.
Good. Integral of e to the negative 6x is negative 6x divided by negative 6. And then minus 1/2 e to negative 2x, and integral of this is just x. And, oh, we don't put plus c, we have c1 and c2 in the first part. Now, these puppies simplify. So it's 1/2, negative 1 over 12, because 2 times negative 6, right? And then e to the 4x minus 6x is e to negative 2, so 1 over e 2x downstairs, minus x over 2e to 2x again. Perfect. So this thing is yp, particular. The answer to our question is C1e to something an hour ago, 4x, plus C2e to the negative 2x, minus 1 over 12. I'll just put e to negative 2x because yes. And 1/2 x e to the negative 2x is fine. It's good enough. You can combine this two into C2e to the negative 2x term because this negative 112 gets absorbed by the constant, or you can leave it. Let's check one more problem, because you love this so much.
Now we can use this method to choose problems on the first exam, right? Where you're not going to have
Well, you're not going to have the homogeneous case, so you can't. If you use f of x equals 0, it kills both integrals, right? So, no, only yp would be 0. That was problem 48. At one point, someone was complaining about me not featuring the hyperbolic functions, so I'm very sorry. Let's feature hyperbolic functions. I mean, it would be bad if the first time you see it is the exam, you know. So. Beautiful, right? So you know what to do. R squared minus 4 equals 0. Let's go, while we're still young.
Yeah. Another C1 E2X. All right. We don't know. So we just take E2X and negative.
All right, let's take a look at this problem together. Wait.
Now that equation is going to be the y of h of x equals c1 e to the 2x plus c2 e to the negative 2x.
Beautiful. So yh is c1 e to the 2x plus c2 e to the negative 2x. X.
So then we take the E term, so we take the derivative.
So y1 e to the 2x, y2 e to the negative 2x, y1 prime 2e the 2x, and y2 prime negative 2e negative 2x. We do the Wronskian now, which is e2x, e negative 2x, 2e 2x, negative 2e negative 2x. There you go. And now, what happened? Everything good? So this is negative 2 minus 2, it's negative 4. Like this.
If they're not,
It will be 0 and it will be a problem.
so then we can't do it.
Well, you remember that these two are always linearly independent. If you have the repeated, you will have an x over here and Wronskian would work.
But say if they were like,
It's impossible. Remember that these two are always linearly independent. The Wronskian will always be non-zero because of that.
like the negative 2 E to the negative 2x, when you multiply. If you multiply and then subtract from the other multiplication.
Diagonal minus the other diagonal. Diagonal minus the other diagonal.
Cancel out, right?
Yp is negative y1 integral the other one, and then we have sine hyperbolic 2x. I know how much you love this stuff. Divided by negative 4 dx plus y2e negative 2x integral e 2x sine hyperbolic 2x over negative 4 dx. And all we need to do is to integrate this and we're done. What? I'll just write out the solution. Exactly. As Nike would say, just do it. All right. Do we remember the beautiful definition of the sine hyperbolic? Exactly. Yes. So, sine hyperbolic of a heart x is equal to e to the heart x minus e to the minus heart x divided by 2. In this case, we have sine hyperbolic 2x, so all of the hearts are 2's.
I got the 2 parts.
You have 2 hearts?
I got the 2 as an asterisk.
All right.
But the minus parts. That's 868, so.
So once we have the formula down,
I'm just about to write it down.
you got this. So, all right, so you have over 2 from sine hyperbolic, and then this one and the negative, so it becomes 1 over 8 outside. Inside, you have e to the negative 2x that multiplies e to the 2x minus e to the minus 2x, and all of that is dx. And that's the first integral. Plus,
If we get up to yp, how much credit is that? I'm being serious.
20% on the exam too.
20% better than 0.
Yes, it is. So sine hyperbolic x is this thing divided by 2. So 2 times negative 4 is negative 8, and then this negative is positive 1 over 8. Same thing happens for the other one, except negative survives and changes this plus into a minus. And now, 1 over 8 e to the 2x integral. Now, when this multiplies, this becomes 1 minus e to the negative 4x dx, and then minus 1 over 8 e to the negative 2x integral of e to the 4x minus 1 dx. Can finally do some calculus. Integral of 1 is x, and integral of e to the negative 4x is, it's going to be a plus over here, e to the negative 4x over 4, because the negative and negative canceled. Minus 1 over 8 e negative 2x, and we have the integral of this, which is e to the 4x over 4 minus x. Now we distribute 1, 8, 2x, which is 1 over 8 x e to the 2x plus 1 over 32 e to the negative 2x minus 1 over 32 e to the 2x plus 1 over 8x e to the negative 2x. Don't copy me. There we go. I know. Now we have like terms. This guy and this guy and this guy and this guy are like term. Oh, no, they're not. They have x's. No, never mind. Bye. I have 1, 8 x, and that one has x. So, yeah. Yes. So y of x is c1 e to the 2x plus c2 e to the negative 2x plus all of this. 1, 8 x e to the 2x plus 1 over, who picked this problem? It's e to the negative 2x minus 1 over 32 e to the 2x plus 1 over 8 x e to the negative 2x. We're kicking this section out.
Do we have to simplify, or can we just literally have it as the...
Literally leave it like this, okay? Unless we can make this problem much nicer if now you have initial condition, and then you have to differentiate and plug initial condition and calculate C1 and C2. In which case, I will also provide the box of tissues. Yes? I know. I can pull e to the 2x and then have... Since Evan is really into simplifying, y of x equals to, we make it a mandatory for exam as well, right? So... Hold on, comrade, I have to now simplify this because of the popular demand. Yes. He wants to combine this back into trig functions, so we'll do that after I simplify this way. Yeah, he's walking home, apparently.
If I see a problem like that on a test too, I'm just going to give him my test and have him figure it out. Here, this is your problem. You're the one that wanted me.
All right, so this is a simplified version when you factor out e to the 2x and e to the negative 2x. And I haven't wanted all of these to be put together into hyperbolic functions, which definitely they can. So let's do that as well. And then we can have A, B, and C as answers on the next exam. Sponsored by Evan. Oh, there.
Yeah, a lot of people are laughing in.
What happened?
I said a lot of people are laughing in.
Yeah, eventually. So this term here, and where is the companion? This term here, perfect. And then this term here and this term here, perfect. So the checkmark terms, we can factor out 1/4 x, and we are left with e to the 2x plus e to the negative 2x over 2, which simplifies into cosine hyperbolic of 2x. And then the hard terms, the hard is not good. We can factor out 1 over 16, and we are left with e to the, we factor in negative 1 over 16, e to the 2x minus e to the negative 2x over 2, which gives us, yes it is, negative over 16, which is sine hyperbolic 2x. Where is my h over here? Much better. So now, the solution in simplified form would be c1 e to the 2x plus c2 e to the negative 2x plus 1/4 x cosine hyperbolic 2x minus 1 over 16 sine hyperbolic 2x. There we go. And we'll put this one on the test as the final answer. There we go. Beautiful. Now, once you differentiate this twice, differentiate this once, and figure out what the solutions are, you can combine these two terms then in hyperbolic. And then maybe there will be some identities that you can run between the two hyperbolic and so on. So this problem can potentially go on for another 2 days. Another one?
Yes.
Of course, you love this stuff. That's the spirit.
Looks like I'm only at 1%.
What happened? As I have foreseen. How are your trig integrals? Let's see. If I put this problem here, then I don't have to put it on the exam, right?
Yes.
There we go. Have fun.
That's what I'm thinking about. It's
What's his name? Chris Tisdale. Chris Tisdale just told me. Right here. Oh, yeah. Square and take it away.
I don't want to see anything scary from back. Not a lot. I don't want to get spooked again. Come here. How do you get thrown you? Oh, okay. Yeah, actually, I didn't get it. Yeah, there's probably later. I don't want to talk about what color is the no, it's not scary at all. It's just unless you consider mine to be scary. And mine too. Don't want to everyone. Oh, we gotta take a derivative. What is it? It goes code and no, it goes sine no, yeah, negative 3 sine. I got my negative on shit. This zone is going to be negative 3 Is there something I can factor here? Nope. Why? Oh, the 3x. Wait, yeah, what? This is what I got. I gotta take 1 over x times cosine 3x. Oh, that's the whole way. So I'm gonna go plus 3 sine 3x times cosine 3x. Should be some square. Yeah. It's 3. Yeah. So yeah, back her up. Quick question. Yeah. Can you give me your the W factory?
No, I'm fluent too. I'm just not the friends.
Oh, wait. It is 3.
Is it 5
I wrote down 1.
It's 3.
What did you want? Just give us 3. You got it here.
Okay, so it'll work from there.
I don't know what the formula for this one is.
I forget. Alright, so these two will be so okay, you guys are gonna
I just wanted to see how some people square to get to the take that from the middle term.
it's take r squared plus 9, subtract 9,
You don't?
equals 0, so now you get r squared equals negative 9. Right, and then you take the square root of negative 9, but it's a negative, so that's why it's negative. Right. So then we don't do the 9. I squared. So from there, we're like, hey, we are dealing with I, so that would be cosine sine. So instead of, now when you put in the cosine,
So your y of x, or y of t.
that's going to be your y of t. And that's your coordinate.
Y of h.
And then you have C1 over 3x plus C2 and then you make a negative. So you have your, forget your C1 and C2. You just drop, take right side to the x, left side to the x, right away.
So there's no e this one, just like c1 cosine.
Because E was E from AX. Why did you say A is 0? A is 0. A is 0. So E is 0x.
All right, let's take a look. So we start with the first part. We immediately see that this is y equals, this is y age of x. And we see it's clearly c1 cosine 3x plus c2 sine 3x. We all got that part? Nice. The next part is to write that y1 is cosine 3x and the y2 is sine 3x. And then y1 is equal to negative sine 3x and y2 prime is cosine 3. Got it. Wronskian is cosine 3x, sine 3x, negative 3, sine 3x, and 3 cosine 3x. This is 3 cosine squared plus 3 sine squared, 3. Nice. So now we have yp is equal to negative cosine 3x times sine 3x times the function 2 secant 3x, everything over 3, dx plus the other solution is sine 3x integral cosine 3x 2 secant 3x over 3 dx. Now we can kick 2/3 outside, so negative cosine 3x, this is 2/3, negative 2/3, there we go. And we have sine times secant. Secant is 1 over cosine, so this is a tangent. We can't integrate tangent, so we are just going to leave it as sine over cosine. Yeah, we'll use the substitution. Yeah, but I'm not going to write it as tangent because substitution is not clear. Yes, use substitution. And cosine cancel. Nice. I need a 3 1/3 to make the u sub work. So this is now negative 2 over 9 cosine 3x. The integral of cosine is positive sine. So that's going to be, oh, it was negative.
It would be positive 2x.
Yes, at the end. And this over here is 1 over cosine squared 3x plus 2/3 x sine 3x. So this is 2 over 9 secant 3x, when you cancel everything in life, plus 2/3 x sine 3x, and that's it. Done. Walk away.
Wait, isn't that 2/9 ln cosine 3x?
Wait.
Because it's 1 over u.
Yeah, that's an ln.
Don't act like you got that.
I did. I just didn't want to speak up because I thought it was wrong.
Three times 3 on top. That's, you have to get the substitution.
Yeah, this is a u sub over here. We get the integral. Oh yeah, it's yeah. So it's ln. It's ln of u, and a u was cosine 3x. That's better, right?
Yeah.
There we go. All right, so let's just rework all of these at home. Obviously, when you study, you rework these problems, and at that point, it should be clear.
You leave it, once your the final answer is
Now it's the final answer.
Y,
There it is. Awesome, right? And that's it. I'm calling it quits. You know why I'm calling it quits? Because now I have to do the same problems again, except in the word problem setting. Yes. All right, restart the stream.